Season 3 is powered by crowdfunding. Welcome to Oceanside Chat, Light Beyond Generations. This podcast was created to inspire, motivate, and provide insight through industry professionals sharing personal stories, career aspirations, and practical advice. Our team is not afraid to take risks and try new things. This episode was recorded live in the classroom, as evidenced by the echo. We hope to use this as a learning experience to improve our sound quality for future releases. As you will notice, our audio has significantly improved since the last episode. Our guest is Benjamin Lyon, who leads Astra's engineering, manufacturing, and launch and test operations. He previously spent 2 decades designing and manufacturing hardware at Apple, where he most recently held the role of Senior Director of the Special Projects Group. Time to get your feet wet in the business world and join us down by the water as we have an Oceanside Chat. Season 3, Episode 1, The Future of Space Technology and Economy.
Welcome to Oceanside Chat, Light Beyond Generation. I'm Helen Wang, the host and creator of the program. We are recording this episode live at the University of California, San Diego. 140 students from the Innovation to Market class will participate in today's production. I met today's guest speaker as the younger versions of ourselves at Apple. We were both on the team that delivered the early versions of iPod, the first generation of the iPhone, iPad, and many more revolutionary products from Apple. He led an engineering team, and I managed an operation and supply chain team. We worked side by side to enable the transformational process from innovation to market. Furthermore, I encourage everyone to check out his keynote presentation about autonomous technology on the Oceanside Perspective website. Last but not least, I find him striking a balance between an engineering mind, emotional intelligence, and artistic creativity, which differentiates him from most technology leaders. Please join me in welcoming Benjamin Lyon, the Chief Engineer, EVP Engineering and Operation at Astra, who leads the company's engineering, manufacturing, launch, and test operations. Benjamin, welcome to the show.
Thank you, Helen. Thank you for having me here.
So we have a full room of college students. How do you feel about coming back to the classroom?
It's actually pretty intimidating because when I look at all of you, I go, my career is probably half over. Probably is. I'm pretty old. Look how bald I am. And you all are literally our future. And so to me, it's about what do you all need to have the impact on the world that you want to have? And to what degree can I be useful and helpful in that?
Yeah, I mentioned a younger version of ourselves. How old were you when you joined Apple?
I think I just turned 19 when I officially joined Apple.
So early. What happened?
Yep. What happened? Gosh, the story of how I joined Apple, I'm not sure is a story that you all want to completely hear the full version of. But the short version was that I got a call from a senior level person at Apple. And I was at CMU at the time in my freshman year. And the person asked me how would I like to come and work at Apple, to which I told them that Apple wouldn't be around for probably 6 more months and any longer than 6 more months. And I hung up the phone. And so then they called me back and we ended up having a very interesting conversation about where Apple was and how different that was versus where Apple was going and how Steve Jobs was volunteering on an ongoing basis to help turn the company around. And I was amazed to be talking to somebody who, instead of pitching the company as our company is the best company at pick your topic, in this case, consumer electronics, instead, this person was telling me, no, here are all the issues. Here are the differences between Apple today and Apple that we want to become. And would you like to be part of that journey? And that to me was a breath of fresh air. And so I made the leap.
Is that person still around?
On the planet, yes.
Okay.
At Apple, no.
Okay, got it. All right, so that was interesting story. And then I think when you joined Apple, it's about the same age, students here. Does it remind you anything like when you were at that age?
Y'all look a lot smarter than I was at that age.
So back at Apple, I work in supply chain operation, but you led the engineering function. What made us a great team?
Well, I think we were a combination of both similar values and complementary skill sets. I think we both had tremendous curiosity about very, very many things, which made 14-hour plane flights short. And we were able to teach each other some things. One of the things that I admire Helen greatly about is that she really drove a cultural change in much broader kind of consumer electronics business around creating long-term win-win relationships between full system integrators like Apple and their supply bases. And it stopped being so transactional and started being much more strategic and, creating long-term alignment. And I thought that was amazing. So I got to work with you and learn a lot from you, as well as have many, many interesting conversations.
Wow, that come from you. That was a lot. Thank you. I really appreciate that. That actually brought me back to so many good memories that when we worked together on project. I think I appreciate Benjamin the most among many things. There's always a problem that a product designed by engineer, and then they turn it over to you, go make it happen, and go make it happen to the volume we wanted, the pricing we wanted, right? So it's your problem to fix it now. I think Benjamin has the curiosity. He's very interested to know my side of the world, although it's not as rosy and pretty than the engineering side. And then he is interested to go together to our partners, trying to understand their processes, understanding the challenges to push the envelope of technology and what it takes to do it. So I think just that partnership, that understanding, that curiosity made a really, really long way. That's how I really miss working with you. I mean, not every engineer is like this.
But they could be like this, because when you design something, if you understand how it's actually going to be realized, manufactured, operated, used by the end user, you will design a much, much better thing. Whether that's designing a physical thing, a piece of software, designing a process, designing a business process or a business culture, any sort of design, understanding everything down the pipe is core. And your end customer matters because they have to live with your choices, or they may choose not to live with your choices.
Yeah, but I love my engineering colleagues. You're one of the best. I feel like I'm a great problem solver. I've been practiced all this time to solve impossibles to become possible. So when did you know that you wanted to be an engineer?
I think I knew I wanted to be an engineer from when I was 4 or 5 years old. For my 5th birthday, I was also a very late reader. And so my parents really wanted me to pick up with my reading. And my parents knew I was really interested in airplanes and taking things apart. So my mother gave me for my birthday the manual for a 747, the pilot's manual. And that was a thing that actually drove me to really learn to read, because I wanted to do more than look at the diagrams.
5 years old, you already know.
Yeah, actually, it's funny. My mom, when I got my pilot's license, I don't know, like 7 years ago or so, was like the first person who wanted to get in the airplane with me. But engineering was the opportunity to not just use something, but actually create something.
So your mom is your biggest cheerleader.
I think my wife's my biggest cheerleader, but I think my mom's my second biggest cheerleader.
So you have a supporting system. Wow.
For sure.
But if you're not an engineer, what would be your best alternative?
Probably a musician.
Tell me more about that.
I love music. I love practicing. I like improvising. I like playing together with other people. And I like producing as well. So one of my hobbies on the side is I like to produce classical music albums.
Is there anything out there publicly we can listen?
Yes, but I try to keep my name off of most of the classical music. I like the focus to actually be on the artists who are doing and the composers who are doing the work.
All right, got it. What new belief, behavior, or habit has most improved your life in the past few years?
Gosh, I don't know if my habits that have improved my life. I've been very, very fortunate to be surrounded by amazing people who have made my life really wonderful. So maybe a little bit of curiosity has helped me a lot. I love to meet and learn from the people I come across in my life. It's actually one of the reasons why I really like my job at Astra right now, because I get to work with journeyman welders and logistics people, as well as rocket scientists, as well as business folks. And so you kind of span people from many, many different backgrounds, many different locales, and it provides the spice of life. My wife's a professional ballerina and runs a ballet company. And so I get to also engage with her and the people she works with, which is, again, a completely different side of life. And then my kids, I've got a 14-year-old and an 11-year-old who are very willing to tell me exactly how old and out of date I am. So I get to learn from my kids as well.
Wow, so curiosity, that's a great gift. And also, do you get inspiration from music, from arts, from ballet?
Yeah, absolutely. It's funny, like during COVID, for example, one of the challenges that happened very quickly was that you couldn't do in-person music classes or ballet classes. And so that pushed folks to try and figure out how do we innovate and enable doing all of that remotely online, which went directly to a problem of internet connectivity and how do you deal with latency? Because if you're trying to dance together or play music together over the internet and you can't actually align people in different locations in time, that's a big problem. And so that drove significant innovation and improvements in the quality of audio over things like Zoom and WebEx and Microsoft Teams. But it also drove completely new business models. So my wife, for example, went from teaching classes of at the most something like 20 to 25 people to teaching classes of literally between 700 and 900 people all over the world online. And by making that shift, it enabled artists to be able to actually have a living, even though they were no longer able to work together. Those different experiences then take me into my business and I go, it's interesting. The value of low latency connectivity everywhere is a big deal.
So our live audience grew up in the era of internet and smartphones. Compared to the younger self, what they have that we didn't, and what they didn't have that we had.
Ooh, that's a good question. Well, for one, you have access to information that, I didn't have access to and at a much lower cost. So for example, I would have loved when I was in college to have access to Wikipedia. Like if Wikipedia was a thing when I was in college, that would have.
We had dictionary.
Oh my gosh. That was kind of like you had your textbooks, which were crazy expensive, and you had basically various different reference volumes. And today, like if you want to learn anything from key aspects of surgery, if you want to learn orbital dynamics, if you want to learn about business, you can go on to something like Google and you can get tons and tons of information very, very quickly. And that is pretty amazing. So that's definitely something that you all have that we didn't have. And your ability to get that from a lot of different places. Like the internet was much more restricted. Wireless was not really a thing, certainly while I was in high school. But one of the things that I think that we did have was a lot more confidence in the information that we had access to. So deepfake wasn't a thing. Misinformation was much more rudimentary. It was much more easy to distinguish when you were kind of getting information that wasn't true. Now you can, when you go searching for information, you can get a lot of plausible data that isn't necessarily accurate data. And I think that can be a real challenge.
I thought one more thing interesting is because of the internet and smartphones, so we kind of work 24 hours. That's one thing that I realized ever since iPhone, that you can just never stop. But when we were young, the work-life balance was perfect.
Yeah, it's funny, like for those of you who are familiar with like 3D shooters, like first-person shooters and things like that, computer games or Xbox or whatnot, I grew up during the beginning of the first versions of the alphas of something called Quake. And so that was the beginning of people spending time online for hours doing some sort of computer game with other people online or role-playing games or things like that were previously done in person. And on one hand, like during COVID, I think that's actually amazing. All that connectivity allowed people to stay in touch, even though they couldn't physically be together. On the other hand, I've got 2 kids and they struggle to like get their homework done in any sort of a reasonable period of time because they're like watching a YouTube video while chatting with their friends, while doing something on Minecraft, while doing their homework, which is very hard for them.
Yeah.
So attention management can be really challenging.
That's right. Sometimes I'm worried about it when I keep talking, like, do I have your attention or not? I keep checking on those things.
For sure.
That's wonderful. Now you're working for Astra, a launch vehicle company incorporated in 2016. Most people have this big question as to why space matters to us, provided we live in an ever-changing, complex, and challenging environment named Earth. I'm curious about your thoughts.
I would first just say that this is kind of a new frontier. And so no matter what anybody tells you about what the future of space is like, It would be kind of like somebody with a typewriter telling you what the future of word processing, document collaboration, and the internet would be when the internet doesn't even exist in any real form yet, right? But that said, there are things that you can only do from space. When you have a constellation of satellites on orbit, they can see a large section of the Earth. If you're kind of in like geosynchronous orbit, you can see a very large swath of the Earth. But even if you're down at like 1,000 kilometers above the Earth, you can see entire sections of the United States, for example, and see changes in the environment. You can see what happens with crops. You can provide internet to folks who cannot get it through the cellular network or through the wired network. So you can enable rural access to the internet. You can put sensors into space that enable you to measure and then predict extreme weather events like hurricanes, for example, that just happened with Ian. And that will both help society, but it's also good business, because if you can minimize the impact of these things, if you can be predictive, you can actually understand what areas are at risk and target your investments for improving infrastructure on Earth to those specific areas that are most at risk, for example. And so I think there's a lot of opportunity there. The other one, which to me is really interesting, is that on orbit, you have access to the sun without going through the atmosphere. And so for however long a spacecraft is on orbit, it is getting energy from the sun that then can be applied towards compute. It can be applied towards algorithms. It can be applied towards communications. It can be applied towards remote sensing. And so for me, processing at the edge in space where the energy is not coming from a power plant, it's coming from the sun, is a really exciting kind of opportunity, specifically looking at what all the entrepreneurs will do in that space with access to remote compute that's powered by solar.
I picked up a few things from what you just described. First of all, you not only need an inside perspective, which we are living on Earth, we have minimum view and perspective about what happened, but you also benefit a lot from an outside perspective. Therefore, you have a bigger picture in terms of what's going on. So I think that's powerful. And also the energy from the sun, I think it's a resource. Anything beyond Earth, those are the resources available out there, something we should be excited to explore because, we have limited resource on the Earth.
Yeah, no, I totally agree. The other thing that's fascinating, I think, about the emerging space economy is that space is truly international. Your satellite orbits around the Earth. And so the amount of time it's over an individual country may be somewhere on the order of, let's say, 6% of its total orbit. So what is it doing for the other 94%? Hopefully it's providing some great value globally, positioning, timing, emergency communications for, remember, the Earth is mostly water, so for boats on the water, et cetera. What globally will this enable? Not just what locally in the United States or locally in some other country will this enable?
Human being as a whole.
Yeah.
Yeah. Astra's mission is to improve life on Earth from space. So to get people really interested in your mission, could you elaborate what it means and give us a few examples of potential impact?
Sure. One of the things that we've been talking about is access to information. And so the ability to have the internet from space, provide access to Wikipedia, data, communicating between people, I think is super important. Knowledge is power. And the ability to go to school is taken for granted in many places, especially here in the United States. But that's very much not true for many people in the world. And so improving life on Earth for me, one, is access to information and knowledge and the ability to grow as people. The second is about the environment, being able to actually learn way more about how our Earth is operating by looking at it kind of zoomed out as opposed to super zoomed in, which is the kind of bulk of our tools. So I think that is a way to improve life. Another one is global security, which is if you can image from space, then you actually can know the truth of what kind of big things that are going on our planet. And I think that is important for holding governments accountable, especially in this day and age. And then last is, again, through that connectivity, enabling things like doctors to do remote medicine that they otherwise can't do. So those are a number of obvious, how does it matter to me personally or you personally?
What you just described is a few of the biggest challenges I think human beings are going to face. You mentioned about agriculture. So food insecurity is very high list of the importance for us to survive as a human being long term. Also, the access to renewable energy, the utility side of it, we just don't have enough resource that we will need, as well as climate change, right? What you just described is exploring space, utilizing the space resources can actually help us to fighting with climate change, therefore become smarter. We see all the dynamic change going on with climate, and we can also be more sustainable.
That's right. And as the world starts to come up with kind of global contracts for how we're all going to participate in improving the environment, this is actually also a way to hold governments accountable for actually delivering on their promises. Because you can see things like smokestacks pushing out pollution into the atmosphere. You can see temperature plumes in the ocean. There are many, many things you can observe globally that then can help back up those kind of global deals to make the whole world better for everybody, that I think will give them better chances of actually succeeding.
Our topic is twofold today. One is space economy and then the space technology. But if we do the economy first, I looked for the definition of economy. Although we say it every day, what does that mean? According to the dictionary, economy is the wealth and the resources of a country or region, especially in terms of production and consumption of goods and services, and carefully manage of those available resources.
Well, I think the space economy is a mixture of providing access to space. And that is both the ability to go to an intended address in space, because, for example, you can go to an address in space where the sun is not lighting up the same area of the Earth the same way every time. But that's okay because you may need your satellite to go over that area for communication purposes, for example. But if you're doing photography, then you need an address where you're going to have the sun lighting up the same area every time. Otherwise, you have different problems, different challenges. So one is access to space, both in time at a reasonable cost and to the right address. So that's one kind of offering. It's one thing that's provided that customers consume. When you're in space, the actual satellite itself is another thing that once it's on orbit can provide basically services. And so there's a whole service economy that can be built up in space around sensing, compute, communications, et cetera. And then the last is actually you don't want space junk. And there's a lot of space junk left over from the Cold War, and we don't want more of it. And actually, we'd really like to get rid of some of what's up there. And so having the capability to, at the end of life, for example, remove spacecraft from space, there's actually a whole business around that is beginning to develop, as well as some new ideas, kind of new business models around building a spacecraft that can actually go around in space and either breathe new life into aging spacecraft that may have run out of fuel or for some other reason they're no longer working and you can make them work, or to capture them and then bring them back down out of orbit to clean up space.
The key being part of the economy, you have to participate, right? As the definition said, all the resources shared by all the participants. So in the context of space economy, who are the producer? Who are the consumer and distributors? And what role does Astra play?
Yeah, it's a great question. It's evolving very, very quickly right now. I think it's very clear that SpaceX has basically created the most cost-effective container ship that gets you to space. And part of that's because Elon's been focused on getting to Mars. And so he is building a vehicle and actually a complete launch system, a space access system that is bigger and bigger and bigger in order to support a human journey to Mars. There have been side effects of that have been great, which is being able to build something that it can take many, many payloads and reduce the cost of an individual payload. But there's a downside of that, which is the service that is not provided is going to a specific address in space. And you have to wait until you can fill up the entire container ship for it to be cost effective to actually have that container ship fly, or in this case, fly to one address in space. So then that leaves, when you get dropped off in space, months upon months where the customers have to move to their intended address in space. So SpaceX has figured out that container ship strategy, and I think they're doing a great job of it. I think then there's a whole slew of companies like Rocket Lab, like Astra, like ABL, and others that are working on the access to space piece for much more like a FedEx truck, where you're trying to get your package delivered exactly to the address you want it to go to. And you want that to be at low enough cost that you can have that delivery directly to where you want to go, even though others don't want to go there. So dedicated access to space. And so that's one role that Astra has. And then the next piece is providing on-orbit services. through the development of a spacecraft, a constellation of spacecraft, and then software to actually manage that constellation. And there's kind of two pieces to that. The first is the core technology set to enable it. Astra is involved in providing in-space propulsion, allows the spacecraft to remain in the intended orbit. It allows it to do collision avoidance, so it can move out of the way of another spacecraft and then move back to where it wants to be. And then at the end of the life, that propulsion system can actually deorbit the spacecraft. So that's a real business as one of kind of the core technologies. And there turns out there aren't very many providers of that, especially since one of them, which used to be out of Russia, is obviously no longer available to the rest of the world. And then lastly are actually the data services, the on-orbit data services. And so, for example, Starlink has provided tremendous customer broadband service. The experiment is still ongoing. How you make that a cost-effective business. To date, much of this work is highly subsidized by the government. So then who are the customers, right? One customer is obviously the government, both for research purposes, for oceanic research, for NASA, for NOAA, and then, of course, for security. That's been kind of the traditional player. One of the things that's emerging now are many kind of new entrepreneurial ideas about mapping for autonomous vehicles, mapping for agriculture, sensing weather for logistics and being predictive about it. And so those are all new customers that just shown up really, in the last 5 years or so. And I'm really excited to see, like, as the cost of getting into space goes down, how that commercial space customer set grows and grows and grows.
So on your website, you said we are now contracting dedicated launch services for payloads up to 600 kg to low Earth orbit. What commercial payloads are being sent into space?
So obviously I can't talk about our customers individually because they like to do their business in private. Their business is their story to tell, not my story to tell. But I think it's safe to say that our customers are focused in the areas of sensing the Earth and the environment and around imaging and taking pictures and maps and things like that, and communications, both to support agriculture as well as other communications applications.
What is the size of the global space economy?
That's a great question. There's a view that if you look out to when all the mega constellations come online in the next, call it 5 years or so, that the total addressable market, so the TAM, is somewhere around $1 trillion. Now, with kind of the recent events in the economy, it'll be interesting to see to what degree does that stay on that timeline or does it stretch out as we go through kind of the process that the world is going through right now, recovering from COVID.
Who are the main investors for this economy?
It's all the usual investors that you see that jump into new tech. So you see the BlackRocks of the world, for example, jumping into this space. But it's really any of these venture capital firms that see that there's an emerging market that has a lot of possibility, and we don't know yet exactly how it will pan out. There's an old saying that Steve Jobs actually used to make, which is you don't get to bet on the horses after they've left the gate. But what it really means is that these firms, their core expertise is placing bets really early, because that gives you the maximum opportunity for upside growth if that bet pans out.
We talk about space economy, and it is a booming economy. What are the key themes driving a boom in space economy, in your opinion?
So there are a few things that are really driving the space economy right now, and this really is kind of a new market, so I think this will definitely evolve. It turns out that there are many folks who have no access to the internet right now. And that means that they have less access to information, less ability to do their jobs. For example, imagine doctors today, they're very much connected to the internet. They research their patients' symptoms on the internet, and that helps them make better diagnoses and then provide better treatment to their patients. There are many places in the world where doctors do not have access to the internet, and so they end up actually either providing delayed response to their patients or just lower quality of care. So connectivity is key. People being educated, people being able to do their jobs. Another is that understanding the impact of climate change and then figuring out what to do about it, both doing it culturally as well as holding governments and countries accountable for whatever they sign up to in terms of reducing emissions and the like. the ability to watch the entire world from space enables you to not only keep governments accountable, because you can see what's happening on the ground, you can see pollution, but you can also observe what's going on in nature, thermal currents in the ocean, extreme weather, and get much better at being predictive about those things, modeling kind of, okay, if I make this decision, what impact will that have in the next 10 years, 20 years, 100 years on the climate of the planet?
How have the government side reacting to that private sector is getting involved with the space? And how does the private sector view this opportunity?
I think there are two pieces to it. On one hand, the government definitely wants to support the commercialization of space. So moving the main customer of space from being just both the government research side like NASA and NOAA and the government kind of security side like Department of Defense and NSA over to being a new public industry. And so there's actually a lot of support for new space companies to provide solutions like launch. And part of the way the government does that is by helping fund things like universities putting satellites on orbit, which is great. And those satellites on orbit usually are doing some sort of research. So they're looking at tropical storms, they're looking at the ocean, they're looking at agriculture, they're trying to understand deforestation, those kinds of things. So that's the good side. The other thing that's also true, and it's funny, I think it happens in every new industry, is that the technology is developing ahead of all of the regulatory environment. So, up until a decade ago, really up until 5 years ago, the main customer of space was the government. And so the whole kind of regulatory environment around how do you regulate a commercial space industry is something that is really kind of in its nascency today. And again, that's part of the reason why I thought it would be great to go join Astra, was because then I could actually personally bring a set of values about how that should go. And that's everything from thinking about how do you operate at a rate that provides value to a rapidly moving industry, all the way to how do you mitigate space junk and how do we set up a global set of expectations around not leaving garbage in space, for example.
You did such a good job as autonomous technology when you compare the robot with all the human sensing. I hope you could do as good a job for space technology. So could you explain to us what are the foundational technologies required for space?
Sure. Well, you got to get there, right? So you got to get from Earth to where you want to be in orbit. And the address you're at in orbit for each individual satellite really matters. And then when you're up there, you have to be able to stay on that orbit, or you need to move from that orbit to the orbit you want to be at. And you need to be able to operate for some number of years. And then, as importantly, you need to be able to deorbit afterwards so that you're not leaving junk up in space. So the key aspects of that system are fundamentally propulsion. So the ability to conquer gravity, compute and controls. Think about the brain of the rocket. You basically need the virtual pilot to fly the rocket to space. And then when you have that satellite in space, you need the virtual pilot to fly that satellite around in space. And the other key thing in space is actually you need communications. So those are kind of the key pieces, like kind of key core technologies that you need to be really great at in order to kind of create the space infrastructure.
What are the main challenges when it comes to technology readiness and development?
Well, they don't call rocket science for nothing. The propulsion piece of rocket science operates at the limits of materials, and you're trying to conquer gravity. So you need a system that is quite efficient, but it can also survive the mission. That's one kind of big challenge. The other is a lot of aspects of a launch system and satellite systems that orbit the Earth are not easily modeled. There aren't like CAD tools where you can simply simulate how it's going to be and then design to your simulation and then expect it to work. So there's still trial and error in this area of technology. And then the last is you are operating in a world of gravity and atmosphere for part of the journey, and you're operating in a space, no pun intended, that is vacuum, has no atmosphere, which means you have the radiation of space, solar radiation and the like, that are things that are actually pretty difficult to test on Earth. It's not like an autonomous car where you can pull it over by the side of the road when you don't like what it did and pull the fleet back, make some fixes, and then try again. When you do a launch to orbit, you either make it or you don't. So that's very different.
So what scientific researches are enabled by space exploration technology?
Well, the way I would think about it almost is you can either look inward or you can look outward. If you look inward, you can do lots of atmospheric research, oceanic research, human population research. You actually can look at things like traffic and learn about traffic patterns, agricultural shifts, like if there are insects that are destroying whole areas of agriculture on a continent, you can learn about how those populations are moving. And of course, you can look at tropical storms and learn how they work and be better at predicting them. You can flip around and you can look out into space and you can learn a lot about how we got here in the first place. A great way to think hard about where you want to go is to make sure you know where you've been.
So do you think all those important research you just mentioned, does Earth's future depend on space?
Well, I don't think I'd be arrogant to be able to say that for sure, but I certainly believe that where we sit here on Earth, what we can see is very narrow. And when you get up, 1,000 kilometers above the Earth, you can see a lot more, all at the same time. And then as a human society, having connectivity everywhere, I do think is important. I think the more connected we are as people across the entire planet, the more we will understand each other, be curious about each other, and hopefully develop into a better society.
Well, a very cool question from students. With the invention of space vehicles, is there any hopes of us ever creating a time machine?
I believe the answer is no, that there are not hopes of creating a time machine. I think as we understand physics today, that creates a problem.
Benjamin, always opportunities comes with risk and challenges. So as space becomes more congested, the threat of space junk in orbit, the debris from the old spacecraft and satellites to new satellites and rocket launches has grown. What are the risks of increase of this exploration?
Yeah, this is a great question, and it's something I'm really passionate about. One of the reasons why I think it's good that Astra focuses on low Earth orbit, it sets the number of years before a spacecraft comes back down again as a finite number of, that's measured in a couple of decades, and with deorbiting capability can be reduced to like 5 years, as opposed to being out in like mid-Earth orbit or geosynchronous orbit, where it can be measured in hundreds of years if you don't have a way to bring it back down. So to me, first of all, we talk about how often technology development is ahead of the regulatory environment. And Astra is actually very active with a global set of players, really advocating for regulating globally or kind of asserting globally that spacecraft must have a way to come back down. And so you either put them in a really, really low orbit where they're going to come down very soon, or you enable them with a technology like propulsion in order to make sure that they really do come down at the end of life actively. So that's one piece of it. The other is today, the bulk of the stuff that's in space, that's space junk, is left over from the Cold War. And so as long as we're not adding to that, we really do need to go figure out how to bring as much of that down as possible. While Astra is not deep into that business, other than providing core technologies, there are companies that are working on that problem directly. From a risk perspective, it's important to realize that if you look at the diameter of the Earth and then you zoom out to the diameter of an orbit, there's actually a lot of space. And a spacecraft itself, like the really big ones, are the size of like a Volkswagen bus. And the ones of the future are really like the size of like an office refrigerator. So as the efficiency of RF goes up, as the power density of batteries goes up, as well as the efficiency of solar cells goes up, all these things will drive spacecraft to be in, who knows what the future is, but my bet is that it's going to be somewhere in that 350 to 850 kilogram range. And so those are physically not that big. And so you can't have many tens of thousands of them up on orbit. The key is you want to make sure that they're coming back down again so that you're not just continuously adding and creating space junk.
I toured a satellite factory many years ago, and I asked them about what's the life cycle of a satellite. If I remember correctly, about 15 years.
Yeah, the old view of satellite lifetimes was that you'd make a satellite that maybe it cost $500 million, maybe more, and it was very big, and it would live its effective life often geo satellites, its effective life would be something like 15 to 25 years. And then when it was done, it just stayed there. And that is not my personal view of the future.
Do we have any idea like how many are just sitting there waiting to be collected?
So I don't off the top of my head, but you can actually go. One of the things our government does do is it tracks everything that's up there. And so you can actually go online and see everything that's up there. And you can actually visualize it, which is pretty neat. You can see, for example, every Starlink satellite that's up there, weather satellites, satellites that have been sent to space from China and from Russia, in addition to the United States, et cetera. I show my kid, like in one of these stargazing applications, hey, look, that's that University of Oregon satellite that my company put into space, and it's going over our house right now. You can see it. They think that's really cool. Suddenly, dad became cool.
The FCC announced in a new rule recently, satellites that no longer in service must get out of the sky within 5 years to help decrease the amount of garbage in Earth's orbit. What are your thoughts about that?
As we were just talking about, I personally believe that this 5-year horizon is a really good idea, with the exception of things that have a useful life that is longer than 5 years. So you could say 5 years from the end of useful life, for example, is a good way to do it, because you want to be able to get the value, right? You're burning fossil fuels to get things into space. You want to get the maximum value out of that thing on orbit so that you're minimizing your use of fossil fuels, for example. The issue with things that are on orbit, if they're in low Earth orbit, they're coming down and they will burn up in the atmosphere unless they're dense enough that they can make it all the way down to Earth. The things that are of concern are the things that are in MEO and in GEO synchronous orbit. So they're far enough up in altitude that the time for them to come back down is measured in much longer periods of time. And for those aging kind of holes of satellites and of rocket bodies and things like that, as they get radiation from space, if they start to come apart, that is the concern that's really being brought up in this article, which is that small pieces can come off. And you don't want those small pieces then coming around and hitting something else that's on orbit. In terms of the ability to know what's up there, a lot of what rockets are made out of is metal. And metal looks pretty shiny to a radar, especially a high-tech radar. So that's one way of knowing what's up there. The other is when you put satellites in space, you can point cameras down on Earth. But you can actually have those cameras pointed the other direction and look at what else is up in space. And that is useful both for understanding what space junk is up there. It's also useful for security purposes, as you can imagine, knowing what other countries have up in space.
Great. I'm going to start picking up students' question. Here comes the first one. What's the most important thing you would like to improve Earth's life from space?
For me, connectivity is first. And then the second is the ability to understand. I was going to say understand weather, but it's really to understand in our environment and the relationships between the systems in our environment. So ocean, weather, terrestrial, pollution, et cetera.
Here's another question. How much funding do you need for deploying a small satellite to space?
The core technology that goes into a satellite is not all that complicated. But if you know how to make a computer, like a desktop computer, especially if it's a laptop, you're not far off from being able to make a satellite. The things that you have to kind of do in addition to that is test it really, really well, because you have to convince the government that it is, one, not going to send wireless signals that are going to interfere with everything else going on in space. And then the second is that it's not going to come apart in space and create a space junk hazard. So the actual development, you can build a small CubeSat for tens of thousands of dollars and put that up into space. Now, the satellite itself is not that expensive. The access to space, however, is quite expensive today. And so that is where coming up with solutions that are right-sized for folks will help improve things dramatically. Because today, if you want to fly like on a dedicated launch, $8.5 million, all the way up to like when SpaceX does a dedicated launch that they did earlier this year, it's like, more than $60 million for that dedicated launch. And so that is not making space for everyone. That is expensive and difficult for folks to get access. And so driving that price down is important. Now, the other thing folks can do today is they can wait, because there are these missions called transporter missions, which do have a minimum price, which is over $1 million, but you can basically wait and have your payload aggregated with everybody else's payload and then take the flight, twice a year or something like that. The downside of those missions is they go wherever the primary customer on that mission is going, and everybody else that is on it is stuck with it. My hope is that we can get the cost of access to space to a place where, and this is not soon, this is, call it over the next decade, where it's like the total cost of being able to get to space with like a single experiment, this thing you want to test, your entrepreneurial idea, is total under like $50,000. That would be really, really cool. By the way, that's not Astra saying, that's just Benjamin's hope of where I'd like to see the future be. But there's significant challenge in making that happen.
What is the biggest difference between the work you did for Apple versus Astra? What are the best parts of both of them?
I loved my work at Apple and I love my work at Astra. I think the best parts of both is that you get to work with all sorts of people who come from all sorts of different backgrounds. One of my favorite things about Apple was working with people all over the world, where I would travel all over the world and get to meet and spend time with people literally on every continent of the world, except for Antarctica. And so that to me was like super, super cool. And I personally felt like I became a better person and learned a lot through all of that. And I think the other cool thing about Apple was the opportunity to solve problems for people and then have that problem be solved for millions of people. And that was really awesome. Like, for example, Touch ID is a great example of people not using security on their phones or their iPads. And I'm like in a technology company going, your information is super, super precious. Your privacy is super, super precious. Your bank account is super, super precious. It should be protected. And so we were able to come up with an idea, which was Touch ID and then eventually Face ID, that said, hey, you don't have to do anything extra. You don't have to type in a password, et cetera. By default, suddenly be protected with security, with a password. And we literally went from the majority of people by default not having security to the majority of people having security over the course of weeks. And that's millions upon millions of people. So that was really, really cool. The attractiveness to me about Astra has been that, one, it's a very, very hard set of problems. Getting to space is, rocket science is called rocket science for a reason. It works at the limits of materials, the limits of our ability to model systems. So the technology piece of it's hard. The business piece of it is also hard. The thing that I love about it, though, is that it's about building the infrastructure for the future. It's like a chance to build the foundations of the internet. And when the foundations of the internet were being built, I was in high school. So I didn't get the chance to be part of that. And so to me, that is like a really exciting thing, because it's not about telling people what they should do. It's about building a set of enabling infrastructure that then they will be able to figure out what they want to do on it. And I'm like excited to see what comes of all that. It took me about a year of looking at Astra before I decided to go help. And what I was seeing was a lot of closed approaches that were really about kind of creating a closed system that created barriers to people having freedom for operating on the system. And that's not the internet. And what I want is the internet of the future. So I thought that Astra would be an interesting place to do that experiment. And the people there are really great. So it's fun. I get to learn about all sorts of things, like learning about cryogenic systems, zero gravity environment, zero atmosphere environment. These were all new, different challenges, working with completely different areas of the government. Where I launch from is 200 miles off the coast of Russia. And so every time I did a launch out of Alaska, I wanted to make sure that I didn't create a global political problem. Those are really interesting, different kinds of problems than the kinds of challenges that I dealt with at Apple on a regular basis.
So how did your experience at Apple connected or enabled your work at Astra? And what were the transferable hard skills and soft skills?
Yeah, so it's a great question. On the soft skills front, being curious, knowing that I don't know everything. As a matter of fact, I know I don't know a lot, meant that I could come into a company like Astra and learn about cryogenic systems, learn about the regulatory environment around launch systems and space, learn about combustion. All those things were not really things that I learned about in the world of robotics or the world of consumer products. Things that I could take over, though, were one, it turned out that actually a launch system is an autonomous vehicle system. It's a robot that flies on its own to orbit. And then the spacecraft that lives on orbit until it comes back down again is also in a fully autonomous system. And so those were very transferable skills in terms of the kind of hardware architecture, software architecture, robotics and control systems, and things like that. On the soft skills side, good leadership is also good leadership. Being willing to be influenced, being willing to influence on the merits of your ideas, not because of what your position is, recognizing where my own weaknesses are, and therefore where do I want to complementary skill sets. Those were useful leadership skills. At Apple, I had this experience of taking early technologies, turning them into productizable technologies, and then taking them all the way through to mass production and impacting millions of people. That journey from prototype to product is something that was useful and is certainly currently useful for my role at Astra.
So how many rockets will you be launching in the future? And by the way, the students noticed that a second rocket has launched in Florida, but payload does not reach orbit.
Yes,
is that right?
That's correct. Actually, to put like a total note on it, I launched 4 rockets so far in my time at Astra. Half of them made it to orbit and half of them did not.
As a young company, how do you think the company balanced the profitability and innovation?
Oh, it's a great question. Well, let me back up for a second. In my life, how do I think about innovation? I think that's actually a really important question to ask, because often people ask me, how can I innovate? And I go, gosh, I never thought about innovation as like, that is the thing I'm off to do. Usually I'm faced with something really important that I want to go do. And it's in the process of solving those hard problems to achieve that goal that the innovation actually came from. And that's true everything from like a heartbeat sensor or a fingerprint sensor, all the way to developing autonomous cars or to developing a low-cost rocket that can actually get to orbit. Those challenges are all very, very difficult. And it's looking back on them, you go, oh, the way I solved that problem was really, really different, unique, competitive moat. And now how am I going to protect that, leverage that, et cetera? That's the key thing.
Okay, so we move on to the next question. We emphasize that innovation is actually an ecosystem, meaning like not one company, one person can just make things happen, right? So what are some of the main drivers and applications within this new space ecosystem? Give us some concrete examples.
Sure. So if you're going to operate on orbit, there's something really, really cool about it, which is that you get energy for free from the sun. In order to get the kind of maximum value out of that, you need a solar system, like a solar cell, solar panels, as well as an energy storage system. So a battery and a battery charger and a power conditioning system. So how you deliver that energy to your radios or sensors or whatever it is, the application it is that you're enabling on that satellite. That whole system is all ripe for improvements, because small improvements in that area actually have dramatic total capacity impacts. What that can enable then is putting things like edge compute on orbit. And now instead of running things like AWS compute services in a data center on Earth that is pulling power out of the grid that may or may not be renewable energy or some fraction renewable energy, you can push that to orbit and do all of that processing on orbit using completely renewable energy. And for many years, because you're not sitting inside the atmosphere, you're not on Earth, you don't have to deal with weather, those kinds of things.
How is Astra's objective different from Starlink?
So I think it would be bad for me to speak for Starlink because I don't work at Starlink. But what I can say is that at Astra, we really believe in building kind of the internet of the future in space. We really believe that we want to enable all the entrepreneurs, all the research in space. And so as we think about the platforms that we build, we think very hard about interoperability and making sure that what we build will click into the rest of the future space infrastructure, as opposed to building a completely closed system that will not.
So do you think students, our younger generation, should be interested to join the space industry? And what kind of skill it takes to be successful in that industry?
I think space tech is really interesting. I love how it requires such a broad cross-section of skills. And I love that it's emergent. When I was growing up, there were people building the internet. So I didn't get the chance to do the internet. I did get the chance to do kind of the digital wallet revolution, the mobile device revolution. We got to work on a lot of that together. And I think that you all actually are at that interesting point in time that in the next few years, when you're actually deciding to go off and enter the workforce, you do have the opportunity to have an impact on a future economy and ecosystem that is not currently truly known. Like the one thing we know is that it will change, and it will change significantly. So it's nice because you can be everything from the business side to the operational side to the technology side, many different kinds of technology, and actually adjacent sectors. Like you could be in medicine, but thinking very, very hard about how do you do telemedicine and the like.
How will space travel be made affordable, or is it only reserved for the rich?
It's a tough question. I don't know the answer. I honestly don't know the answer. Beating gravity is tough. And part of what we're doing at Astra is we're going the opposite direction. Instead of making a big, large human-rated thing that is super expensive to fly every time, even if it's reusable or partly reusable, going the opposite direction and creating something that's much, much smaller and therefore accessible to many more folks. But it's not human-rated. It's basically a FedEx truck for space. It's delivering packages. So I don't know. I think it will be very, very hard to get to a place where just on the cost of consumables and quite frankly, impact to the environment, burning a bunch of fossil fuels to fly people to space, if their role in space is not to improve life on Earth, to me, that's questionable. So it'll be interesting to see what happens. Never say never.
Oh, that's fantastic. And I wanted to ask you, what are your final thoughts to share with our audience?
Well, I'll go back to what we were saying at the beginning, which is you are our future. And, the most valuable thing you can do is decide where you spend your time. And the one thing that is not infinite for any of us is time. And so for me, I'm spending my time here because I think it can be a thing where I can do some good. And I would encourage you all to think very hard about, given that time is your most valuable resource, where are you going to spend yours?
I couldn't agree with you more. That's why I'm teaching, and hopefully that working on the future generation make the earth a better place. So thank you so much, Benjamin, for spending time with us. And we really appreciate it. Thank you.
Thank you.
Thanks for listening to Oceanside Chat. We hope you enjoyed this conversation. If you liked it, please share this podcast and stay tuned for our next episode. We'll see you later.